All right, new toy. I thought this would be good for the channel. It is a Keithley 924. Now, you know, when I was young, this was like the dream DVM. I was like, ooh, you got a Keithley, you know, and look at the buttons. And this thing is a 6.5 digit resolution meter. So back in the day, it must have been very, very expensive. And it does have the spec sheet for it here. Let's see here, 1 gigohm input. That's pretty nice. Let's see here, accuracy. It gives the 5.5 digit accuracy, 0.004. Yeah, I'm not quite sure. I need to read the data sheet for the absolute accuracy here, but it is 6.5 digits, so it has to be pretty good, right? This one doesn't work, so repair video and see if I can get it working. I have a particular YouTube video commenter. I don't know if he's a subscriber or not. I have to bug him if he's not. And he's asking about how do you have a calibration standard in your lab. Now, I've covered calibration standards for frequency. You can get a rubidium standard or one of those GPS discipline things, and those are great. What about a resistance standard? Well, I showed some 0.01% resistors that are just individual resistors. You can buy those. I have some decade boxes that are 0.02%, and then a big decade box that's 0.05%. So those are pretty good. Obviously, you can get calibration boxes to do a lot of stuff. But what about voltage? What is 1 volt, right? How do you find out what 1 volt is? And unfortunately, there's really no good standard for 1 volt. There used to be Weston Standard cells, no longer made, it seems. There's Josephson junctions, but they don't seem to be absolute. I think the Weston was an absolute number based off of chemicals and stuff, but I believe the Josephsons aren't absolute, but they're stable. So it comes down to, well, then how do you calibrate the calibrators? And so this has a very, very stable internal, you know, calibration standard. Basically, it has something that the box can refer to. I think it's a 2 volt standard inside. And but it means that you have to calibrate this against something. So once you have something calibrated, then you can calibrate other things. So if you have a 7.5 digit meter, maybe you can calibrate a 6.5 digit meter. If you have a 6.5 digit meter, you can calibrate, you know, other things. I have 2 6.5 digit voltmeters. They don't quite agree with one another. They're close, but they don't quite agree with one another. I've looked into getting them calibrated. It cost me somewhere between $100 to $150 to get one calibrated, and it's just not worth it to me for the garage. You know, I really don't care. One of the reasons that you get a 6.5 digit meter is not for the absolute accuracy, but to watch relative drifts and stuff. You can watch things drift slowly and stuff, so that the relative nature of 6.5 digits is very, very valuable. The absolute nature in the garage you don't really care about. But yeah, let's see if we can't get this thing working. It's DC volts, AC volts, kiloohms. Notice there's no current, so this thing will not measure current. And then 0.2, 220, 200, 2000, 20 meg ohms. So these are for the voltages, and then it goes up another range here for 20 meg ohms. And then an auto, program and recall. So it has a GPIB. Programmability, nice big LED display on it. Let's go ahead and hook it up. Uh-oh, nothing. Do we hear anything? Don't hear anything. So, okay. Let's see what we can do here. Power's off, cord's off. See if we can take it open. Oh, well, before we open it, let's see if let's just see if it's a fuse. That'd be embarrassing, wouldn't it? Let me measure the resistance of this fuse here. Yeah, fuse is fine. All right. So, it's not the fuse. All right. Cool. All right, want to see inside? Big shield. Stacked boards, a board underneath, a board on top. Transformer marked Keithley. Let's see, I don't see any. Here we go, a whole bunch of, can you see that? There's a whole bunch of hand-marked resistors here. Somebody's calibrated this once before. 20 meg, 2000, 20, yeah. So each range has a gain setting to it. There's probably a 0 setting somewhere, so every time you want to fit something linearly, you need to have offset and gain. So there's probably an offset adjustment someplace, and then these are all the gain adjustments for the various ranges. And the shield looks like it just, it's on these little clips here. Oh, there we go. Oh, there we go. Let's take a look inside. Yeah. So here's the voltage reference. You can tell because it has a little plastic, oops, it has a little plastic thing on it. So this is just for insulation. It is probably a 339. 399, I'm sorry. LM399. And it has a Sharpie mark on it, so it might have been selected as well. It has a Sharpie mark on it. Probably means it passed. And as do a couple op amps too have blue paint on them. This is an LF351. I'm not familiar with that. LF351 and LF351. Yeah, so these are probably selected also. They might measure the offset. Like, remember, like I had that one Lucky 741. These might be Lucky LF351s. Something on a socket. Everything else is not on a socket, so that might have been replaced once. It's an LF351, and it does not have paint on it. So that's kind of a giveaway. That one probably was replaced at one point in time. Here's another LF351 that has brown paint on it. There's another blue one over there. Interesting. So, couple expensive resistor. That one there. That one. Probably some really high impedance. Can't tell from the outside what it is. This is a 108, so that sounds pretty high. There's a whole bunch of traces going to it, so it might just be a divider. And here's another one over here. So there's some expensive Caddick resistor things. Big relay. That's interesting. Look at all of these. Can you see that? Can you see all of these transistors painted? We got orange ones, and yeah, I bet you here's a bunch of green ones. These are painted green. I got a whole bunch of, oh, these are all green packaged transistors. I don't know if they're, wow. So yeah, I bet you there's a lot of selected parts here. To get to the 6.5 digits, they had to select parts. That probably drives up the cost, doesn't it? Well, let's see, what do we got here? I don't see any test points. There's one thing here. I don't know what that is. I don't see any test points labeled. So how do we know if we have any voltage? Well, there's an LSO2, 74 LSO2, so there should be 5 volts on him. So let's hook up the power again. Let me turn on a voltmeter and turn the power on, and I will measure across the 7400 chip. Oh, I'm getting 5 volts, 4.9 volts, 4.97. So there's 5 volts going into this thing, but there's no display. Interesting. No display. Well, maybe there's just a loose connector or something onto the front panel. That would be the next thing I'd be looking for. Well, that's interesting. There's a wire here this connector's not hooked up. High voltage AC is not hooked up. Oh, hopefully somebody didn't remove something. All right, let's turn off the power and let's see what the next step is. Why don't we take the rest of the case off? Interesting. It's not releasing. Oh. Yeah, I don't think this works. I don't think this works. I think the bottom board is screwed into this thing here, so yeah, we're not going to take the bottom off. We'll have to take that top board off so we can look underneath it. All right, this is back out again here. Let's need a different kind of screwdriver. See if we can't take the top board out. Interesting, long screws. Okay, the board is loose. And where does it lead us? Where does it lead us? Oh, cool. Oh, can you see inside? This board is on a connector, so let's take him off. Just flip him over. Oh, gosh. Well, there's with that connector for the front panel. That's not operating. Here's the power supply down here. So I think the best thing to do is take this board out altogether. So let me take a picture of the wiring so I can get it back. All right. Take all of these off. Flip that out of the way. There we go. And can I just lever this out of here? It's awfully tight. Let's see. Wow. Well, there we go. Got it out. Jeez, that was in there. That was in there good. Okay. Let's put that aside. We have microprocessor because we have ROMs in here. Wow, look at that. Got some ROMs. 3 ROMs. Hitachi 6432s. 2732s. Yeah, 2732s. That's a lot of programming for a little voltmeter. Let's see, here's an 8225 and a 6522. So that sounds like a microprocessor, 6522. Here's some RAM. Looks like 2 RAM chips. NEC 2114s. We got more rails over here. Nothing's marked on the PC board though. I hate it when they do that. Why don't they mark the PC boards? So does it mean the microprocessor's not running? Is that why we get no front panel? Should we reset the ROMs? Or should we look to see if it's actually trying to run a program? It's interesting. So when you design something like this, you worried about noise from the digital circuitry getting into the analog circuitry. And so here's a whole bunch of optocouplers that separate the digital from the analog, right? The analog connects to here. And these are just buffers. It's all optically isolated, so you can separate the grounds. Why don't we trying to figure out how to start. Let's look at the power supply, I guess. It's usually what you start with. Let's give that, see if we can see any strange voltages anywhere. Turn on the scope so we can see if the capacitors are dead, if they're ripply or not. No, I haven't gotten a schematic yet. It's on my computer, and I didn't print it out yet. Let's see. I guess I can plug this in. Okay, where's a good ground connection? It's always an interesting dilemma. Where's a good place to clip onto ground? And which ground? So, I say this is probably ground, and that's probably ground, and that's ground, that's ground, and that's that ground. I think this is ground here. I'm going to take a chance, call that ground, and let's take a look at some capacitors, turn it on, and let's get the scope working over here in a second. All right, let me move you over a little bit. All right, so hooked to ground, looking at one of the capacitors, it looks fine. This capacitor is negative, but it looks fine. This capacitor is positive. It looks fine. This capacitor is negative. He looks fine. This capacitor is positive. This capacitor is wiggly. This capacitor is very wiggly. That's not good at all. Oh my goodness. That's not good at all. Okay, so that capacitor is dead for sure. What about this big giant one here? Let's see. We can go over here to a 7400 part. Let's look at its 5 volts. About right there. Oh, he's wiggly too. That's 2 volts per division, so 2, 4. Yeah, that's bad. That's bad. Let's make sure the grounds aren't separated here. Let me put a ground. Let me put a ground across this part here. Oh no, he's okay. He's okay. So I think the big cap is good, and the grounds are isolated. So the only cap that seems to be bad is that one. Would that make the front panel not work? I don't think so. I think the front panel would work anyway. That's not a good sign. Not a good sign. Let me turn this off. I'm gonna solder some ground. This is a good ground for the AC part. I want to solder a good ground for the digital side so I can clip something on here. So whenever you're working on something, if there's not a good ground test connection, well, add one. All right, I've soldered a ground here for the digital side, so a good place to clip my leads. And we can come along over here and we can take a look at these RAM chips. So there should be some data on those RAM chips. Yeah, there we go. Some kind of data. Kind of ugly, but data on these old computers were not the best in the world. A lot of times there's tri-states and stuff that happen in there, so you get these intermediary values, but things are going up and down at least to 4 volts, which is still a legal high. Let me look over here on the ROM. Yeah, same kind of thing on the ROM. Now there's some runt pulses in there that I don't really like. Those in there. But those could be tri-state things too. You never know. So there might be something better, but it does seem to be trying to do something. We do have 5 volts. Let's go back and look at that 5 volts. Yeah, 5 volts is nice and high. There's no ripple on it. So why would like a minus 15 on the end? You'd still get a display on the front panel, so something's goofy somewhere. Let's come over here to this connector where the front panel connects and see if there's any data going to the front panel. And I do not see any data going to the front panel. Well, what does that mean? Does that mean it got sent once and don't need to send it again, or nobody has pressed any keys? I still don't like the looks of that. Well, I think it's time to break out the schematic, and we definitely at least should change that one capacitor. I think the other ones are still okay. See, here's, yeah, see, this is the difference between the two grounds. This is, I'm clipped to the digital ground, and this is the analog ground. So there's probably like a 60 hertz something or other between the two of them, yeah. But they definitely are separated. So if I clip onto the analog ground, I'm going to look at those voltages again. I'll have to turn this down a bit. So this is 510 something or other, and this one is really high. I don't know why it's so down high. Yeah, 20, 40, that's like 50 volts. 50 volts minus, and this one is 50 volts plus. All right. And then this one is, let's turn him up a bit. 10, 20, almost 30 volts negative and wiggly. Okay. All right, we'll go from there.